Hello, I welcome you all. The problem reads that the automobile has a weight of 2,700 pounds and is traveling forward at 4 feet per second when it crashes into the wall. If the impact occurs in 0.06 seconds, determine the average impulsive force acting on the car. Assume the brakes are not applied. If the coefficient of kinetic friction between the wheels and the pavement is 0.3, calculate the impulsive force on the wall if the brakes were applied during the crash. The brakes are applied to all the four wheels so that all the wheels slip. Okay, so this problem is coming from the Engineering Mechanics Dynamics 13th edition by R.C. Hibbeler. So we want to use the concept of impulse. So what is really happening here? The car is moving in this direction, and at the time when the car is in contact with the wall, okay, this is the wall. At the time it's in contact, there's going to be a force exerted on the car, and the same force of electromagnetic on the wall, okay, and this force is going to be the same, right? So this force, okay, from the wall on the car, okay, it's going to be applied on the car over a certain period of time, and in this case they've given us 0.06. This is when the impact itself occurs, and this is what we are calling the impulse. And this impulse will change the momentum of the car, okay, it will change its velocity. All right, so let's start doing the calculations. So we expect, if we are to redraw this car here, let's redraw it. Okay, it must not be the same, but we can just draw something that looks like the car. Okay, so there we go. So this is the car. Okay, this is the car. Right, we have the wheels like so. So we're saying this car will experience a force from the wall like so, and of course the velocity of this car is in this direction. Okay, this is V, this is the force. Okay, right, this is the only information right now. So we are going to have two cases. Okay, so the first case is case 1, no brakes applied. Okay, this is the first case, no brakes applied, and we are using the principle of momentum, linear momentum and linear impulse. So what do we have? So we have force, summation of force, delta T, this is equal to M delta V. Remember, here we're just using scalar quantities, but this impulse itself and linear impulse and momentum are vector quantities. By that we mean they have both direction and magnitudes. All right, so what do we have here? So we are saying this is going to be our direction that we are choosing, this direction like so. Okay, this is our direction. Okay, this is our acceleration in that direction. Okay, because we want to consider this force from the wall. All right, so what do we have here? So we are saying we have, of course, delta V is equal to Vf minus V naught, and in our case here, our V final is equal to 0, okay, and our V naught is equal to minus V, which is equal to minus, so this one is minus V, which is equal to minus 4, right? This is our initial, but it's in the opposite direction, right? And then what do we have? In our summation of forces, so we'll have V and our delta T. Our delta T is equal to 0.06, right? So we have F delta T equal to M, and our M is just equal to 2700 divided by 32.2 M delta V, and this we said is just V final minus V naught. So what is our F? We do not know, so it's F by 0.06 seconds, and we do have our mass 2700 divided by 32.2, which is our mass, and then we have V final, we said is 0, this is coming to a stop, and then minus 4. Okay, therefore the impulsive force is equal to 2700 divided by 32.2 by 4 divided by 0.06. So this gives us a 5590.06 pounds. So this is the first case. Let's move on to the second case. In the second case, the brakes are applied. Okay, the brakes are applied. So second case, brakes are applied. Okay, all right, so we can say brakes are applied. This is case 2, right? So in this case, brakes are applied. So what do we have? I'll get the same car, just copy it, bring it here like so, and then okay, let me bring it down here, just move a little bit of this stuff there like that. Okay, I bring it back here. So what do we have here? Right, and then here we have friction in this direction, and then we have the normal force, right? So this is the normal force, and then this is kinetic friction. So what do we have from this equation? From this equation, of course, this is the direction of our force, so that is our reference. That's the direction of our force. So we are saying the change. So here we'll have force F minus Fk, okay, times delta T, and this is equal to M delta V. And our delta V just V final minus V initial. Right. And what is our V initial in this particular case? Of course, our V initial is given already. You will know it already. It's the same one like in the other case. It's equal to -4, and V final is equal to 0. And of course, we have M also here equal to 2700 divided by the acceleration due to gravity. So if we had to work out this, and Fk, our Fk here is equal to let's say summation of forces in the y equal to ma y. Okay, going up in our reference, we know that our ay is equal to 0, and therefore our n minus w equal to 0, and our n is equal to w. Therefore Fk is equal to mu kn, which is just equal to 0.3 times 2700. Right. So now let's plug everything in. So we have this is in the same direction. This one here is not minus, it's in the same direction. This is plus. Right, so F plus 0.3 by 2700. Alright, then this times the time it takes, which is just a 0.06. Okay, then this is just equal to, let me write this somewhere down here. My space is limited. So we are saying F plus 0.3 by 2700, and this one by 0.06. This is equal to the mass 2700 divided by 32.2, and then we have V final, which is 0 minus 4. So making F subject to the formula, then we have 2700 divided by 32.2 by 4 divided by 0.06 and minus 0.3 and 700. Alright, so we have a 4780, right? A 4780 point 0.06 pounds. Okay, so 2700 divided by 32.2 by 4 divided by 0.6 minus that 4780.06. Alright, I think this is about it. We are done. So this one is with no brakes. Okay, this one with brakes applied. Alright, so we have in the first case the force is higher. When the brakes are applied, it reduces a little bit. So I think this is about it, and I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.